8.6, Writing linear equations. Best fitting line. The best fitting line is a line that lies as close as possible to the points in a data set. Example 1. To write an equation of the line with a slope of -2 and a y-intercept of -5. First, write down y equals mx plus b. Now you want to enter what m is and what the y-intercept is. If you look back up in the problem, slope is -2, y-intercept is -5. So where there's the m, you want to fill in the slope. Where the b is, you want to fill in the y-intercept. I am happy with this answer, and this is actually what I would circle. If you wanted to continue to simplify, you could actually get rid of the plus negative and change it into a subtraction. Again, I don't care which one you do. You can just keep the addition of the negative. Go ahead and try this checkpoint. Write an equation of the line with a slope of 4 and y-intercept of -3. Remember, your equation of a line is y equals mx plus b. You should have y equals 4x minus 3. Again, I will also accept the answer y equals 4x plus -3. Example 2. Write an equation of the line shown. Well, this time they don't just give us the points, they give us a graph. First, we need to find slope. So remember, to find slope, you pick a y. I'm going to do it to the right here. I'm going to pick 4 first. Remember, it's y's first. Subtract y, which is 2. Over your x's, which x goes with 4? 3 minus 0. Then subtract. 4 minus 2 is 2. 3 minus 0 is 3. You can see they did the exact same thing over here. 2/3 is your slope. Now we need to find the y-intercept, or b. This graph does show us where the line crosses the y-axis. Right here at this point. So we know that point is y equals 2. So at the y-axis, it crosses over at 0, 2, so b is 2. Now we need to fill in our slope, 2/3, and our b, 2. 2/3 goes in for m, next to the x, and for b is 2. This is my answer. Example 3. Writing equations of parallel or perpendicular lines. Write an equation of the line that is parallel to the line y equals 8x and passes to the point 0, 3. First of all, if you remember from when we talked about parallel lines before, because we know the slope of the line that is parallel to it, the slope is 8. This is the same slope we are going to use for our new line. The parallel line passes through 0, 3. So what's the y-intercept? Well, anytime you see the 0 first, that means x is 0, which is telling you your y-intercept. So this is your b. So the y-intercept is 3. Again, the equation of the line is always in y equals mx plus b. So rewrite y equals 8x plus b. Part B asks you to write a perpendicular line to the line y equals -1/2 x plus 3 and passes to the point 0, -5. The only thing we need to know about this equation is the slope. I do not care what this number is at all, this y-intercept. We do not use that. Because remember, we are finding the new line that is perpendicular to this line that they gave us. So all you need to know is that because the slope is -1/2, you take the negative reciprocal, so flip it, 2 over 1, make it positive, which is 2. Again, we flip the 1 and the 2, make it a positive because it was already a negative. Now the y-intercept, so if you think about what your equation is now, you have y equals, we know the slope is 2. Keep the x. The y and the x are always variables. We do not use this point in for that equation. It's y equals 2 is my slope, x is a variable. Plus, we use the point now to tell us b. The point is 0, 5, so the y-intercept is 5. I'm sorry. This should be -5 up here. They just wrote that wrong. The perpendicular line passes through the point y through 0, -5, so the y-intercept is -5. And again, I also will accept -5 as your answer. So this can also be your answer. Either one works. Go ahead and write an equation of the line for number 2, 3, and 4. Remember to pause the video so you can try this yourself before I reveal the answers. It's important that you are actually practicing this. First thing we have to do for number 2 is find slope. So I'm going to take 5 minus -3 over 4 minus 0. Add the opposite. This is 8 over 4, which simplifies to 2. Y equals 2x plus, okay, now they didn't give me a graph, so how am I supposed to find b? What they did give me was a point that has x as 0. That means that there's the b. So you can look at the point when it's x is 0, you'll find your b. So your answer is y equals 2x plus -3. Again, it does not matter if it's subtracting or adding a negative. The next one, write an equation of the line that is parallel to y equals 3x plus 2. Again, I don't need this number. This number means nothing to me. The only thing I want to know is slope. And passes through, oh, there's your 0. X is 0, so there's your b. It's parallel, so I use the same slope. Y equals 3x plus 4. Number 4. Write an equation of the line that is perpendicular to y equals 3x plus 2. Okay, I don't need this number again. This is my how it's going to help me find the slope. I want the negative reciprocal because it's perpendicular. So let's flip the 3 and the invisible 1. And then it was a positive 3, so I'm going to now make it negative. So this should be, let's try that again. It should be -1/3. Alright, so y equals -1/3 x. Again, keep the y, keep the x, plus, what's b? You should say -2. And again, subtracting is the same as adding a negative. Example 4. Approximating a best fitting line. The table shows the number of elementary and secondary school teachers in the United States for the years 92 through 99. So we're going to put a table together. X is 0 through 7. Where did I get the 0 through 7? It's the years since 1992. So this is 92, this is 93, this is 94, and so on, and 7 would be your 99. Here are the number of teachers in 10,000s, so 282 10,000s, and so on. Approximate the equation of the best fitting line. Here's how we do that. First, make a scatter plot. So these are your ordered pairs up here. 0, 282. So at the 0, we go to 282. You can see they put it in, already plotted it. 1, 287. 1, 287 is about there. And go ahead and make a scatter plot. So you have different points on the graph. Don't draw the line yet. Next, Draw the line that appears to best fit the data points. You can see this scatter plot is not going to be a line, but I'm going to draw a line as close to the points as possible. You want about the same number of points above the line as you do below it. So you can see I have probably 1, 2, 3, 4 points either above or close to above the line, and 1, 2, 3, 4 points below the line. Again, it does not have to pass through any of the data points. It does not have to pass through. Oops, sorry. Finally, write an equation of the line to find the slope, estimate the coordinates of 2 points of the line. Alright, so I think, well, we definitely have this point right here. You can see because that one passes through. If you don't have one that passes through, find one that's as close as possible. And this one I definitely knew was a line because it was 0,280. And I started there and ended there. So I'm going to use these two numbers to find slope. Here we go. Take y, subtract y, over x minus x. 50 over 7, it's approximately 7.14. Again, I'm okay if you leave it as a fraction. Leave slope as a fraction. You know the line intersects at the y-axis at 0. There's that 0. That means that's x. So what's this number? B. So the y-intercept is 280. Write your equation. And again, I would also accept 50 over 7. X plus 280. I like to see my slope as fractions because I can see my rise over the run. Note that 2006 through 1992 equals 14. If you go back to part B, actually let me go back quick. It says predict the number of teachers in 2006. So that means 2006, well, what is 2006 minus 1992? We need to get this number just like we got 7. And that is 14. Oh, sorry. So, 14 is the number of years after 1992. This is your x. Because if you go back to the chart, we're just putting it back in the chart here. And here's your x, so this is 14. Now, what would y be if x is 14? Plug it in to the equation. This equation that you just got here. Plug this number in. Substitute it. Take your calculator out, multiply, add it together, you get 380. Please make sure you go back and review the PowerPoint. Make sure you truly understand how to write a linear equation.